Hello everyone, welcome to our next lesson. Today's lesson is on the binomial theorem. And what we are going to be doing is we're going to be expanding our binomials to the power of n. The way to expand a binomial to the power of n is we've got this binomial coefficient, n choose 0, n choose 1, and so forth, all the way to n choose n, times our first term, which is our a to the power n, a to the n minus 1, so forth until you get to a to the power 0. Then we look at the next term, which is b to the power 0, and then b to the power 1, b to the power 2, all the way to b to the power n. To figure out these numbers, you can probably already see there's a lot of patterns there. So for instance, whatever this number is, that will be your top number in your binomial coefficient. The number on the bottom starts at 0 and it goes up all the way until you get to the number n. Your first term is written and it's to the power n, and then it goes down by 1. n minus 1, n minus 2, all the way to 0. While your second term does the opposite. It starts at 0 and then it goes all the way to n. So for instance, if we had 3x plus 5 to the power 4, it's equal to 4 choose 0, 3x to the power 4, 5 to the power 0, and so on and so forth. And you can read it. Questions you would see from IB would be, for instance, if you had 3x plus 5 to the power 4, they may ask you to find the third term. They may ask you to find the term containing x to the power 2. They may ask you to find the coefficient of the term containing x squared. They may ask you to find the constant. You need to know what all these words mean. So for instance, all of these that are separated by pluses are all called terms. The numbers in front of your x values is called the coefficient. So if this was, if this one was 81x to the power 4, your coefficient is the 81. Your constant is the only one that has x to the power 0. So it is the one that only has a number. So for instance, this one is equal to just 5 to the power 4. There is no x's involved, and that's why this is called your constant. So if you were answering these kinds of questions, well, let's just look at each one. Find the third term. So the third term, we've got this lovely little formula here. So if you want the third term, well, if you look at that and you're going to make that a 3, that tells you that your r value is going to be 2. So that's equal to, well, what is n? N is 4. R is, we said r is 2. A, what's our first term, is 3x. To the power of n, what's n? N was 4. Minus r, we said is 2. Times b to the power, no, not b. It's 5 to the power r, which is 2. And that would be your third term. Then you just multiply it out and solve for the term. If they wanted x to the power 2, well, for this one, you should realize that this, you wanted the 3x to the b to the power 2 to give you the x to the power 2. So there's a little bit of just common sense for that kind of question. Find the coefficient of the term containing x to the power 2. Once again, we're looking at x to the power 2. Just when you give that answer, if they're asking for the coefficient, just write the number, don't put in the x to the power 2. And if they ask you to find the constant, well, that's the one where it's x to the power 0. If you want a more challenging question, I've seen this on IB, where you have something like this, where you have 3x to the power 3 plus x to the negative 1 to the power 7, and it wants you to find the term containing x to the power 9. So for this question, what I do is I look at this, and I try to figure out where would we get x to the power of 9? Which term would give me x to the power 9? I'm not so concerned about the numbers right now. So I know that n is equal to 7. What I don't know is what r is. So 7 choose r. Then we got the first term, 3x to the power 3 times 7 minus r, and x to the negative 1 to the power of r. Now once again, we don't care about the numbers for now. We just want to figure out what the r value is. What would give me x to the power 9? So I realized that this is going to be x to the power 3 to the power 7 minus r, x to the negative r is equal to x to the power 9. Once again, I'm forgetting about the 3 just because I'm not worried about the numbers at this point. And this is going to be x to the power 21 minus 3r minus r is equal to x to the power 9. So I've added my exponents together. Then because we've got the same base of x, we could say 21 minus 3r minus r is equal to 9. Negative 4r is equal to 9 minus 21. Negative 4r is equal to 12 negative, and therefore r is equal to 3. Now that I know r is equal to 3, I can expand, I can go back where it's going to be. Once again, it's going to be 7 choose 3, 3x to the power 3 to the power of 7 minus, my r value is 3, x to the negative 1 to the power 3. And if I expanded that out, I would get the term that contains x to the power 9. Hope that helps. Have a good day.